Over 2 weeks ago, the James Webb Space Telescope took its first observations of the mysterious interstellar object passing through our solar system, 3I Atlas, and it took this long for NASA to finally release the results. Interestingly enough, these results came out almost immediately after the Sphere X observatory results of 3I Atlas emerged. Both of these telescopes, by the way, being infrared telescopes capable of carrying out extremely detailed and accurate spectroscopy of objects in space, although generally they're only supposed to be detecting the composition of faraway objects like nebula, galaxies, that sort of thing. But given the mysterious and controversial aspects of this object, apparently NASA thought it was worth their time to point both of these telescopes at 3I Atlas to try to decipher its mystery. And, well, unsurprisingly, both of these telescopes were unable to solidly identify what 3I Atlas is, how big it is, and most importantly, what it's made out of. But the most important thing that we have learned from James Webb is that whatever this object is, it differs considerably from any comet or asteroid that has ever passed through the solar system in the past, at least any comet or asteroid that we have observed in great detail. And in addition, another study came out recently about the possible technological aspects of interstellar objects that included a lot of interesting information about Oumuamua, reinforcing what we always knew, that Oumuamua also was radically different from anything we have ever seen before. Good afternoon, alien enthusiasts, and welcome to another Angry Alien Bulletin. Once again, 3I Atlas, I just can't stop talking about this object because we keep learning new things, groundbreaking stuff, and we've been waiting so long for the James Webb observations and imagery. I just had to put this out as quickly as I possibly could after the James Webb results, data, imagery, etc. came out. So as much as this channel might look like a 3I Atlas channel at this point and nothing else, I assure you that once this stuff slows down a bit, my content will start to diversify again. Hey, at least I'm still covering Starship launches, staying up to the wee hours of the morning 2 nights in a row now, only to watch them scrub the mission. Hopefully that doesn't happen a third time in a row and we actually get a flight out of that rocket. If you want to watch that, by the way, it's going to be a hell of a show, regardless of whether it actually successfully flies or blows up. So just make sure to watch your notifications when that's going to be coming up. And if you haven't hit that subscribe and notification bell, you absolutely need to do that. Okay, let's talk about the James Webb results. Very strange that NASA took this long to give us some sort of analysis of what they were seeing, but then again, it's very possible that it took them this long to come up with some kind of theory, some kind of explanation, if we're talking about natural explanations anyway, for what we're observing with this object. And unfortunately, I don't think NASA really came up with an effective natural explanation for what we're seeing because, as you're going to see in this video, this object, in spite of the fact that it's starting to look a little bit more like a comet, maybe starting to see the kind of elements that we might expect in a cometary coma, really, when it comes right down to it, this thing is radically different than anything we have ever seen passing through the solar system before, and even NASA is starting to admit that now. As always, I'm going to be quoting extensively from an Avi Loeb article in Medium on this topic. He came out with this hours after the James Webb data became public, so let's go ahead and see what Dr. Loeb has to say. Quote, "A few seconds before my flight to Copenhagen lifted off the ground at Boston's Logan Airport, I received an email with the paper reporting the first Webb telescope data from August 6, 2025 on 3I 3I Atlas. The 15 minutes of wait for the onboard Wi-Fi connectivity to show up felt like an eternity, but the wait was well worth it. The stunning Webb data from a 6.5-meter infrared telescope with unprecedented spectral sensitivity was worth the wait. In short, the Webb data confirms the existence of a massive carbon dioxide gas plume around 3I Atlas with significantly lower levels of water. Finally, water is being detected, but at unprecedentedly low levels, as you're going to see here in a little bit, and also carbon monoxide at a very low level, as reported a few days earlier by the Sphere-X Space Observatory team. Whereas the Webb telescope has much better spectral and spatial resolution, Sphere-X mapped the spherically symmetric CO2 plume 100 times farther from 3I Atlas and demonstrated that it extends beyond 348,000 kilometers. We're talking about a CO2 halo that's half the diameter of the sun. Absolutely enormous. Now, 3I Atlas does not feature a cometary tail, very strangely, that extends beyond the width of its coma, as was already evident from the higher resolution image taken by the Hubble Space Telescope. That this tail is not seen suggests that 3I Atlas does not shed a lot of dust particles with a size comparable to the wavelength of sunlight, 0.5 micrometers, and that the reflected sunlight originates from the surface of 3I Atlas. So once again, if there were a lot of dust being shed by 3I Atlas, then the smaller dust, the smaller particles, should be blown backwards by the solar wind, creating a huge cometary tail. This happens all the time with comets, and yet it doesn't seem to be happening with this object, and yet it's still incredibly bright. This suggests that the reflected sunlight originates from the surface of 3I Atlas and not from the halo surrounding it. This implies a diameter, as I said in the previous video, of up to 46 kilometers. The data from James Webb stands up to this estimate for an albedo of 5%. Now, what if 3I Atlas had a higher albedo, if it was a lot more reflective, like perhaps metallic, or maybe even a mirror, something along those lines? How big would it be then? We'll find out in just a moment. Infrared spectroscopy of 3I Atlas at a heliocentric distance of 3.32 astronomical units was taken with the James Webb telescope, and the spectral images at wavelengths in the range of 0.6 to 5.3 micrometers reveals, as I said before, a prominent carbon dioxide dominated coma with enhanced outgassing in the direction of the sun, as well as the presence of much less water vapor, carbon monoxide, water ice, and dust. The derived ratio of CO2 to H2O output by number of molecules is 8, which is the highest ratio by far that's ever been observed with a comet. This data implies an intrinsically CO2-rich nucleus. The low abundance of water vapor is very surprising, given the object's distance from the sun. The spectrum of 3I Atlas shows a prominent CO2 gas emission feature, along with, as I said before, weak H2O and carbon monoxide emission features, and a prominent water ice absorption feature. So there appears to be water ice, but it's not outgassing, it's not sublimating, which is very, very strange. The inferred mass loss rates from 3I Atlas are 130 kilograms per second for CO2, but only 6.6 kilograms per second for water and 14 kilograms per second for carbon monoxide. The H2O mass loss rate is only 5% of the CO2 output. This is 16 times more extreme than expected for a typical comet at the same distance from the sun. This again is directly from the study. This is not Avi Loeb's interpretation. If the optically thin dust plume makes a small contribution to the total reddened spectrum, the flux detected by Sphere-X at a wavelength of 1 micrometer from 3I Atlas suggests a nucleus with a diameter of 46 kilometers. This implies that the mass of the nucleus of 3I Atlas is 1 million times larger than that of the previous interstellar comet comet 2I Borisov and several million times as massive as Oumuamua. This huge gap in mass is surprising, since we should have discovered numerous objects of the size of 2I Borisov before discovering a 46-kilometer interstellar object. Moreover, as Avi noted in his first paper on the subject, the amount of rocky material per unit volume in interstellar space is smaller by a factor of 10,000 than the value needed to deliver into the inner solar system one giant rock of this size over the decade-long survey conducted by the Atlas telescope. The Webb image at a wavelength of 1.2 micrometers shows no cometary tail behind 3I Atlas. The glow around 3I Atlas could originate from the reflection of sunlight from fragments of CO2 ice that 3I Atlas is shedding rather than dust. These icy fragments evaporate in the sunlight and create the extended spherically symmetric CO2 cloud around 3I Atlas, but that doesn't explain how bright it is. The brightness, once again, must be coming from the nucleus, at least based on the data that we have so far. The CO2 mass loss amounts to the ablation of a millimeter-thick layer of the surface of a 46-kilometer object over a period of a few years. In other words, a relatively thin outer layer is sufficient to maintain the observed cloud of CO2 gas around 3I Atlas. What lies under this outer skin remains unknown. The high CO2 to H2O ratio is puzzling, as I mentioned before. There's only one previous comet, as you can see here, with a similarly extreme CO2 to H2O ratio, named C2016R2. But as you can see from this image, there is a clear cometary tail behind this comet. It doesn't look anything like the plume around 3I Atlas. The James Webb team conjectures that this anomalous composition of the gas plume surrounding 3I Atlas might be the result of high reflectance or reduced heat penetration through its surface. If we increase the albedo from 5% to a maximum value of 100% for a mirror, for example, this reduces the estimated diameter from 46 kilometers to 10 based on the SphereX data. This still poses an untenable demand on rocky material in interstellar space, and also I can't imagine a natural object that would have an albedo of 100%. A way to resolve the discrepancy between the mass reservoir of rocks in interstellar space and the unexpected discovery of this massive object is that 3I Atlas was not drawn from a population of rocks on random trajectories, but instead its trajectory was designed to target the inner solar system, which, based on its trajectory, which I've mentioned a number of times, this object already looks like it was intentionally targeted at the inner solar system. It adheres to the plane of the ecliptic, it passes within 1 astronomical unit, actually a lot closer than that, to 3 different planets in the solar system, and when it comes the closest to Earth, it just happens to be passing on the opposite side of the sun, hiding 3I Atlas from our view. Now, in closing, Dr. Loeb mentioned a particularly interesting detail about 3I Atlas. To put this object into perspective, a human produces about 1 kilogram of CO2 per day. The mass loss rate from 3I Atlas is 130 kilograms per second, which amounts to the CO2 output of about 10 million people. A space platform which measures 46 kilometers in diameter could potentially host 10 million humans or some other types of biological passengers that emit CO2 if they were packed about as densely as humans are on Manhattan Island. But remember that I mentioned Oumuamua? What have we learned about the first interstellar object to be observed passing through our solar system? So very intriguing once again to give you an idea of what all of this might mean. If we are only showing slight traces of carbon monoxide and water and all of this carbon dioxide, it may very well be possible that this is not a comet at all, but some sort of very large asteroid. Once again, could be utterly colossal, over 40 kilometers in diameter. And for it to be an alien spacecraft, spacecraft is not beyond the realm of possibility at all. The idea of using an asteroid ship, as I've mentioned in previous episodes, is definitely something that an advanced civilization would use. Even our civilization might make use of asteroids as spacecraft if you're talking about interstellar travel, because the more protection you can get from cosmic rays, especially if you're talking about travel that takes decades, centuries, millennia, whatever, the more protection you get, the better it's going to be. And there's nothing that provides better protection than loads of rock and maybe even a little bit of ice too, because water provides incredibly effective radiation protection, which is why they use it in nuclear reactors. All that having been said, though, another very intriguing thing was revealed today, and that is some data about Oumuamua. Because a number of researchers, some of whom have been harshly critical of Avi Loeb and his nonstop talk about alien artifacts every time we see a mysterious interstellar object coming through the solar system. Well, now even these researchers are saying that we should take interstellar objects seriously and look for technosignatures and maybe even send a signal their way if we can't really determine their nature, can't really determine exactly what they are for certain. So probably a good idea to signal them just in case. And one thing they also revealed was some data about Oumuamua, some things that I always kind of knew, but I never had it quantified. It was very difficult to find any information as to just how unusual Oumuamua was in terms of its behavior, in terms of its non-gravitational acceleration. And unsurprisingly, turns out that Oumuamua behaved in a manner that no other object we have ever observed has ever done. Now, to be clear, this new study entitled Technosignature Searches of Interstellar Objects makes the case that one-eye Oumuamua was not a technological object, and they claim in the body of the paper that the consensus view is that technosignature assertions about Oumuamua are unjustified given our current knowledge, and that the non-gravitational acceleration exhibited by one-eye Oumuamua can be explained by outgassing or radiation pressure from a natural object. But here's the bizarre thing about it. The data that the researchers present in this paper does not support this assertion at all. First of all, let's get a quick rundown of all of the things that Oumuamua did that natural objects don't do. For one thing, its speed and trajectory adhered to something called the local standard of rest, meaning that Oumuamua, before it encountered our solar system, was stationary relative to the stars orbiting around it, meaning that its speed, the rate that it was orbiting the center of the galaxy, corresponded to the overall rotational speed of the galaxy itself. This is a highly unlikely thing and would be incredibly useful if Oumuamua were some kind of navigational aid. In addition to that, by incredible coincidence, Oumuamua also passed through the solar system and conducted a slingshot maneuver around the sun at exactly the right time and speed to make a very close approach to our planet, passing directly through the Goldilocks zone of our solar system and passing within 0.2 astronomical units of Earth. The odds of that happening purely by chance are tens of thousands to 1. In addition to that, Oumuamua was very long, elongated, and thin, either a very thin disk or a thin stick-like object of some kind. That is also very strange compared to natural asteroids and comets. But finally, the non-gravitational acceleration that I mentioned before. This is the strangest thing about this object. As it left the solar system, it suddenly began to speed up in a manner that could not be explained by either solar radiation pressure or the gravitational effect of a slingshot maneuver around the sun. So let's have a look at this diagram. Once again, this comes straight from the study. The little black star is Oumuamua. the orange triangle is to I Borisov. The little green dots are all comets that we are familiar with. The dotted line is the amount of acceleration that generally happens with artificial objects that are being pushed by solar radiation pressure. And then asteroids are the little purple dots. And then finally you have something called dark comets, these little orange diamonds. Now, dark comets are an extremely controversial topic. Even though many astronomers think that they definitely exist, Avi Loeb has demonstrated that at least some of the dark comets that we have spotted are actually artificial objects that we ourselves launched. As a matter of fact, all dark comets that we have seen thus far might actually be artificial objects. But all of that being said, as you can see, in terms of radial acceleration, Oumuamua accelerated more than anything else on the chart except for a couple of comets that had lots of cometary outgassing. Now, by lots of cometary outgassing, that means enormous amounts of visible outgassing that would have caused a big change to its trajectory and acceleration. Oumuamua had no outgassing of any kind, at least not observable outgassing, and if it was some kind of invisible outgassing, well, the dark comets are about as much of a trajectory change that you can get out of invisible outgassing, once again, assuming dark comets are real. And as you can see, the acceleration that you get out of those objects is much less. We're talking 100 times less than the acceleration observed with Oumuamua. The only way that you get substantial acceleration from invisible outgassing is if you invent an object that's mostly made up of invisible gases, say a big chunk of nitrogen or a big chunk of hydrogen that somehow survived a very close approach with the sun. Can't imagine how that could have possibly happened with an object that has that low of a boiling point and then began to emit invisible outgassing, a very large amount of it. However, even if that happened, even if somehow this mysterious miracle object were to actually exist, you would still see debris being spewed out of the object in addition to the invisible outgassing. It requires a lot of outgassing to get this kind of acceleration, as this diagram proves. So even though Dr. Loeb declined to enter into a mudslinging match with these researchers who created this paper, I will be happy to wade into the mud bit here. They have presented data that categorically refutes what they are claiming in the paper. The acceleration observed with the Oumuamua was extreme. Only a few comets have been able to match this acceleration, and that's with lots and lots of visible outgassing. And one other detail, Oumuamua tumbled. It rotated at a very consistent rate, approximately 3 times each day, and that rate of tumbling didn't change while it was accelerating. Even if you had some kind of miracle invisible outgassing that didn't produce any debris in the process, that outgassing should have changed the rate of rotation for Oumuamua if it were natural. And guess what? It didn't change at all. Oumuamua was not a natural object. It bears a much greater resemblance to artificial objects that we have observed in our solar system rather than natural ones. So once again, all of this news continues to flow in non-stop. I'll keep bringing it to you. Obviously, once again, it seems like it's taking over my channel, but at the same time, I have to emphasize just how critical this whole discovery is with 3I Atlas. The fact that it's passing through our solar system at all is an unprecedented event in the history of astronomy. This has never ever happened, at least never happened for as long as human beings have been able to watch objects passing through the solar system. So all that being the case, until we know the truth about this object, until we know what it really is, any new developments need to be reported. It's just too important from a scientific standpoint, and I intend to keep bringing this to you as long as there's news to bring. Also, I've got something very exciting for you folks coming up soon. The folks at Sunline, they are going to be doing a new merch drop, reopening the merch store. I have added 25,000 subscribers in the last month and a half or so. There's a lot of new people here. You may not realize that I actually have an Oumuamua design in the merch store when it reopens, so make sure to keep your eyes open on the description. And in addition to that, we're going to be creating some 3-Eye Atlas merch as well. My idea of what this object might be, and I'll give you a little spoiler here, it's not going to be a comet. So keep your eyes open for that. Thank you very much for watching. Please don't forget to like and subscribe. And if you'd like to support the channel in some other way, to do so on Patreon is the most effective way, and you get access to a library of exclusive titles and a Discord server that is packed with experts in this field, a lot of people who know what they're talking about in the field of both spaceflight and astronomical objects like 3-Eye Atlas. You can join for as little as $3 a month, so make sure to check the description. And until next time, stay angry about space.